50% of individuals adhere from their medication regimen, resulting in over 125,000 deaths annually in the US alone. That's a pretty bad problem. So how have people tried to solve it? Like this, but they all suck. How is this $120 and you have to manually pre-sort your pills first? Or this, how is this one $280? Might just be a scam at this point. But how do these actually help reduce any sort of medical adherence? Simple answer, it doesn't. A, it involves so much sorting. B, it doesn't remind people to actually take the pill. C, what if you misplace it? But there is a solution. There's only one solution. Through the blood, sweat, and tears of Tess, Lucas, Sean, Carter, and Noah, we introduce Mediclock. A pill dispenser, a clock, Mediclock. Mind blown. So, let's see this in action, shall we?
It might seem crazy what I'm about to say. Sunshine, she's here, you can take a break. I'm a hot air balloon that could go to space. With the air, like I don't care, baby, by the way. Because I'm happy. Clap along if you feel like a holy sh.
So now you've seen how it works. Let's dive into the technical magic behind Mediclock itself. First, let's pass it down to Noah, who will talk about the electrical components.
The Mediclock has a large number of electrical components that allow it to serve many different purposes at once and respond to a variety of external inputs. We originally controlled the entire system off of one Arduino Uno board, but because of the large number of components, we had to swap to a larger Arduino Mega, giving us an extra 40 output pins. The electrical components used include an I2C LCD screen to display the time and allow the user to interact with the device, as well as a DS3231 real-time clock module that keeps the time and alarms to serve the clock function of the Mediclock. Our device is designed with no setup required besides plugging into the wall and setting your alarm, and the device integrates two groups of 3 servo motors, a centrifugal pump, and a sonar and Hall effect sensor to create a seamless and convenient medication dispensing system. This, paired with a suitable alarm, flashing LEDs, and a fresh cup of water at your convenience, ensures users will never miss their medication again.
Enough talk about the electrical components. Let's talk about the technicalities behind the pump itself.
The Mediclock has a 2.5 liter tank. This is enough water to last 1 week if the user takes pills in the morning and in the night. We use a 12-volt centrifugal pump to dispense the water. It has a flow rate of roughly 1 liter per minute. There is a contactless water sensor mounted to the side of the tank that lets users know when they need to refill. We also have a lid-mounted UV light that is used to prevent bacterial growth.
In terms of the pill dispensing aspect, I'm going to pass it to Tess and Lucas, who will explain the differences between our V1 and V2 prototypes.
Method 1 for dispensing pills consists of a straw-like hopper in which pills are stacked in, and a brush bottom allowing for different sizes of pills to be dispensed and push past the brush, allowing for some flexibility. They're dispensed via a disc method where a pill can slide into and then is then dispensed when a servo rotates that disc 180 degrees to allow it to fall into a catchment funnel.
So with the second version of pill dispensing, we have a system with a rotating disc that transports pills one by one. One of the neat aspects of this system is that these discs have different holes for different pill sizes, and the fitted hole allows for controlled one-by-one pill dispensing. Since we are using a lot of pills, we chose to use 3 of these systems as each disc covers a variety of pills. One improvement from the previous method is that this system can also be used as a container, where the user just conveniently and quickly pours all their pills into the half cylinder, rather than inserting the pills one by one into tubes.
Now that we've talked about the pill dispensing mechanism, let's go in depth and talk about how the sensors are working. For our sensor systems, we are using 2 different kinds of sensors. the Hall effect, and sonar sensors. The Hall effect sensor is used for the pill tray where it detects changes in the magnetic field. We have a magnet attached to the pill tray, so when we remove it, the sensor will be able to detect its absence. Additionally, the sonar sensor measures the distance between the sensor and the water cup to determine if the user removes the cup or not. If neither the cup nor pills are removed, the alarm will continue to ring. Now that we've seen the technical aspects of Mediclock, let's go through a step-by-step tutorial on how to actually use this. Setting an alarm clock allows you to initialize when the pills are being dispensed. Alarm 1 for morning, alarm 2 for night. But honestly, it doesn't really matter how you use it. When the alarm is triggered, the pumps will start dispensing water for 10 seconds, and at the same time, the pills will dispense into the cup. And the craziest part is that the alarm won't stop ringing until you remove the pill tray. So you better remember to take your pills, or it'll be beeping all day. So after seeing all of that, where exactly did we end up?
We were able to achieve most of our objectives for this project. For example, it dispenses water and pills when the alarm goes. The sensors ensure the alarm doesn't turn off until the pills have been taken, and the water isn't dispensed unless there's a cup there. Also, there's easy button inputs and an easy-to-read LCD. Some things that we still need to fix are that we can improve our dispensing accuracies from both of our pill dispensing methods, and we do not currently have a pill locking mechanism, though we are working on it, and there is still low pill storage capacity, only being able to hold 15 to 30 pills as opposed to the original 60.
Now that we know the flaws, how can we improve it?
To fix these issues, we would like to iterate and improve the current dispensing mechanism. By shrinking down our V2 mechanism and making it more compact, not only will this give Mediclock a more professional look, but also free up space to build increased pill storage. Furthermore, with more testing with edge cases and different shapes of sizes of pills, we hope to remodel and create a V3 dispensing mechanism to ensure reliability and increased pill storage capacity. Moving forward, here are some additional features that we would like to add. Firstly, we would like to have temperature control for the water dispenser. We recognize that our targeted audience, the elderly, like to drink warm water, and adding this feature would create a better user experience and increase our competitiveness as a product. Another feature we would like to add is the ability to set more alarms. Currently, Mediclock can only dispense medication at 2 different times. However, in the future, we want to be able to set multiple alarms to have pills dispensed independently if required. As previously mentioned, we are also looking to install a locking mechanism for the medication storage. We recognize that medication can be abused and is dangerous in large quantities, and we want to ensure user safety by providing caretakers with a secure way to store medication. Lastly, we would like to improve the aesthetics of the Mediclock. We would like to swap out wood and sheet metal for different materials such as acrylic or ABS plastics. This would decrease the bulkiness of our model and also decrease the weight. We would also want to shrink down the clock for increased portability and convenience so that users can take it along with them if necessary.
And there you have it, T7's Mediclock, fully functional, fully working, ready for date. Hope you liked it. See ya in 3:30.
You are my sunshine, my only sunshine. You make me happy when skies are gray. You'll never know, dear, how much I love you. Please don't take my sunshine.